from nest 27 2007 question 14 multiple select question. Consider the integral in given by 0 to 1 x raised to n dx. For n greater than or equal to 1 the integral exists. For n less than 0 the integrand, that is x raised to n, is unbounded but finite over the open interval 0 to 1. For any positive integer m, the product I1 into I2 into I3 up to Im is 1 upon m plus 1 factorial. For any positive integer m, I1 is less than I2 is less than I3 up to I. Okay, so we will start with option A. Okay, we will start with option A. They say for n greater than or equal to negative 1 the integral exists. So we would be happy to check for n equal to negative 1. I negative 1 equal to 0 to 1 upon x dx. Integral of that is ln x. Okay. 0 to 1. Now look here. ln 1 is 0 but ln 0 is not defined. So we typically write it like this. Limit as t tends to 0 from right ln t. That's what we typically write. And we know it doesn't exist. So I minus 1 is divergent because of the limit of ln t as t tending to 0 from right doesn't exist. So I1 is divergent or does not exist. Raise your hands if you understood this. Okay, I1 was divergent. Divergent means if you try to find the limit of a sum, you will always exceed any given real number. Okay, fine. So because of that, yes.
So typically, if you have a particular integral, like part of an integral, like the solution which can't exist, so would that be the entire integral divergent?
Yes.
Sir, in the reduction theory that you had given us a condition that n must be greater than or equal to 3. Then from there, can't we say that option A is wrong?
Okay. No, where I have given that?
In that reduction.
No. Reduction, that formula works only for sine raised to nx. Got it? Don't confuse things. Don't mix up things, okay? Don't get confused because okay. So he is not right. For n less than 0, the integrand is unbounded but finite over open interval 0 to 1. Now let's think about this. N is negative and we have got x raised to n, and x is in the open interval 0 to 1. Okay? Now what can you say about the validity? Look, because x is positive, all powers are defined. Raise your hands if you understand this. All powers are defined because it is open interval and x is positive. Had it been negative, then we would have had trouble with n being 1 upon 2 or something like that. So all powers are well defined, and if you choose n equal to negative 1, then we know that the limit of 1 upon x as x tends to 0 from right is infinity, But if we take the open interval, we can clearly say that integrand is unbounded. Now what do I mean by that? By that I mean, okay, given any real number alpha, there exists x in the open interval 0 to 1 such that x raised to n will surpass alpha. That's what I mean when I say integrand. I'm not saying integral, I'm saying integrand. That is the function that we're integrating. Understood the blue text?
Yes.
Okay. It is unbounded. Can we say that it is finite? Yeah, we can say that it is finite because except 0 everywhere it is well defined. Okay, so we have to say that it's finite. Also it is defined for all x and therefore by definition finite. Okay, so B is right. B is right. Okay, next. For any positive integer m, the product is 1 upon m plus 1 factorial. Let's work it out together now for option C. Yes.
So how did we say it was finite?
Because
It's ultimately approaching towards.
it is approaching infinity, but if I give you any number, okay, if let's say, look, when will it be infinite? See, let me give you a familiar example. I can say that tan x is finite for all x in open interval 0 to pi by 2. Do you agree to that?
Yes.
By finite, what I mean is, if you take any value in that open interval, we can always evaluate tan there and get a number. Got it? That's the same thing which I am saying about x raised to n. But when it comes to unbounded, if we change n, okay, or for that matter, if we get closer and closer to 0, we'll go on getting larger and larger numbers. Understood? So it will surpass every number, but it will still be finite. I mean, that will still be another number. Got it? Huh. Okay. Positive integer, we are happy because we can now integrate this. So it will be 1 upon n plus 1. Correct? So I1 would be 1 upon 2. I2 would be 1 upon 3. I3 would be 1 upon 4. So we can clearly identify the pattern now. 1 upon 4 factorial, so C is right. Understood?
Yes.
Okay, last. What about D? For any positive integer m, I1 is less than I2 is less than I3. Is that right? Just compare I1 and I2. Which one of them is greater?
I1 is greater.
Exactly. So will D be right? No. So C is right. B is right. Yes. ठीक है